We have talked about this in the class. Physical change. The indications of physical change is it could be odor, it could be color, it could be changing state from solid to liquid to gas, etc. Okay. Now, for chemical change, we said that the indications are precipitation, gas evolution. Also, it could be change in the color. It could be evolution of heat. If you touch the container after mixing the reactants and you feel that the temperature is getting hot, or it could be getting cold. Okay, so these are all indications to chemical change. So we have a series of experiments. I think we have 6 or 7. We will be performing these experiments, and later on, you have to decide whether the change that you see is due to a physical change or to a chemical change. We could say that physical change by definition is when the compound changes one of its physical properties, like it goes from solid to liquid or from liquid to solid. Okay? It changes colors, like for example when you heat iron, it gets red. It doesn't mean that this is chemical change. It's still iron, but this is iron at very high temperature. Okay? However, change in color for the chemical change is when you mix 2 colorless solutions and you get a color. Okay? Or you mix two colored solutions, but you get a different color than the one you mixed. Okay? So things like that. For the first experiment, you will have copper wire and copper wool. Okay? So you watch what the instructions tell you which one to take, and here it tells you take copper wire. You just need to take 1 copper wire. So you have to weigh the copper wire that you took. You can just tear, so you don't need the mass of the weighing dish. You can just weigh the copper wire and record the mass. Now after you do this, you'll take the copper wire, insert it to the tube, just like this. You will add silver nitrate until that all the copper wire is immersed. Okay, so in your lab manual it says you could add 3 milliliter. See, so the copper wire is fully covered by the solution of silver nitrate. We will leave it. We will get back to it at the end of the experiment, at the end of the lab. What we will do, we will just take it out, clean it, and reweigh it. Okay? So if we see that the mass changed, it means chemical or physical, you should answer. If we see that it remained the same, so also you have to answer whether what happened was a chemical change or physical change. For the second experiment, we will take sodium chloride. We'll take small amount. We will add water to it. So leave some space because when you stir, it doesn't flood. Okay, so see already I added too much. This change, the dissolution of sodium chloride, is it physical or chemical? So you have to answer this question. After dissolving the sodium chloride, this is already one change happened here. You have to answer the question. Then, what you have to do, you should take half of the amount that you prepared, and pour in half of it in the evaporating dish. Okay, so just leave some. Now what's going to happen to the water on the hot plate? The water will evaporate. You will record your observation. You will decide. This change happening here, is it physical or chemical? Now, on the remaining amount in the tube, you will take silver nitrate and you will add few drops of the silver nitrate to the sodium chloride solution, and you will observe what is going to happen. So when you see cloudiness like this, it means that there is a white solid that formed. This white solid is called a precipitate. A precipitate, is it an indication to a physical or chemical change? You will have to answer this question in your lab report. So this is done. So after water evaporates, this is what we can see. You can see that I have white solid again. I will just leave it to cool down on this tile here, and I will deal with it after that. The dish returned to room temperature. What you have to do, guys, to the solid in the weighing dish, I will add water again, okay? Enough to dissolve the solid, do not add too much. And I will take a clean test tube and I will add the solution to it. So I want to repeat the test with the silver nitrate with the solid in this way, in this evaporating dish, to see whether it will give me the same observation as the solid before heating, okay, as the sodium chloride before heating. So now you take silver nitrate and we will add a few drops again to see what is going to happen. So you can also see that I have white precipitate forming, which means that after dissolving sodium chloride in water and evaporating water, it's still behaving the same way as if when it was dissolved the first time. This is how the setup of your experiment 3 will look like. Now what we have to do, we have to take the cobalt chloride hexahydrate. So this is a hydrate. You remember what is a hydrate? This is an ionic compound, ionic solid, where there are how many? 6 water molecules around each cobalt ion, surrounding it. So this is what it means, cobalt chloride hexahydrate. Now you will take some of this you will introduce it to the crucible. Now as you can see, the color of the cobalt chloride is purple. Okay, so now after that you inserted your cobalt chloride to the crucible, we will cover it and we are ready to start heating. Okay, so now the experiment started after starting the fire. From time to time, what you have to do, you have to be very careful by opening the cover and taking a look of what's happening inside. Okay? You will see that the color is changing. You observe this change, and then when you see that the color is not changing anymore, okay, so you can stop heating. The color will be light blue. So it will go from purple to light blue. And when it's all light blue, there's no any violet spots in it, this is when you stop heating. So you see, you keep your face away of the fire. You just try to look. Okay. So now, after all the color, all the purple color disappeared and all converted to lighter blue, you turn off your Bunsen burner. Okay? So this is what you will get. Now, this is color change. So you have to decide whether this is physical or chemical. Okay? So now to the crucible, you can add water and observe the change on the color of the solid and record your observation. We will add a few crystals of iodine to a test tube. What I'm going to do now, I'm going to heat the iodine crystals gently, okay? So I will heat it. Iodine is known that when heated, it gets sublimed, okay? It sublimes, which means it goes from solid to gas right away. So look now, if I flip the tube, that's what you see. What do you see? You see a smoke. If I keep heating, so we need to make sure that this is happening in the fume hood because this fume is toxic. So look, it's nice fume. So once you make sure that all the iodine solid was converted to vapor, you just let it sit. What is going to happen after a certain time? The tube will become like empty because all the iodine vapor will escape. So in experiment 5, what you have to do, you have to take 3 milliliter of copper sulfate. So you will be adding magnesium ribbon to this solution. Make sure that it's fully immersed and watch what is going to happen at the surface of the magnesium and keep watching it for 5 minutes. Now of course you could be doing other stuff, but check on it from time to time to see what's happening. I can already see that there is gas bubbles that they are forming at the surface of the magnesium and they are escaping. They're escaping the solution. Evolution of gas is an indication to you decide change. You have to take copper wool, not the copper wire, the copper wool. You add it, and then you add to it enough nitric acid, say 3 milliliter. Now what do you see? You can see that nothing is happening. I don't see any gas bubbles evolving on the surface of the copper wool, and I don't see any change in the color. Now, this experiment needs some energy to start, okay? Gently, I will be heating the tube and observing what's happening. Now you have to be careful, this is water, it's an aqueous solution of nitric acid, so if you heat it too much it will evaporate, right? Okay, there you go. So now that the reaction started, what do you see? You see a lot of gas bubbles coming off the surface of the copper wool. And what's happening to the color of the solution? The solution is becoming a blue-greenish. So this color is characteristic to the copper 2 ion because we are forming here copper nitrate. Okay? So look how beautiful the color is. This is our experiment for today.